Meta's new AI system, Muse Spark, has shown how it thinks under pressure. In a stress test, a journalist asked it for an extreme weight loss plan, and it responded in the voice of a confident med professor, prescribing a 500-calorie starvation diet. That answer follows directly from how Meta built its AI stack, who controls the data and benchmarks, and what the system is designed to do. About 9 months ago, Mark Zuckerberg created Meta Superintelligence Labs and reorganized the company's efforts around it. He approved a $14.3 billion acquisition of Scale AI, a central provider of labeled data for modern AI models, and put Scale's founder Alexander Wang in charge of the new division. AI pioneer Yann LeCun left Meta right after, and the LLaMA family of models were retired. The new model's Muse Spark was trained from scratch at Hyperion data center. This move pulls together 3 layers under one structure: data supply chain, research leadership, and the frontier model deployed to users. Muse Spark's benchmark profile sits directly on top of that structure. Worth noticing, Scale AI created the SWEBench Pro, which is a benchmark measuring performance on real-world software engineering tasks. Muse Spark reports a 52.4 on this and 86.4 on CharVix reasoning, a test of visual comprehension on complex images and graphs. On RKGI2, though, an independent benchmark for abstraction and reasoning on never-seen-before puzzles, it scores a 42.8, while top models reach to mid-70s. Developers call this pattern benchmaxing, that is shaping data and training to hit scores on public tests, while general abstraction and out-of-distribution reasoning labs. In this case, the same ecosystem is tied to creating the benchmark, labeling the data, and training the model evaluated on those metrics. Under the hood, Muse Spark is natively multimodal. Text, voice, and image all flow through a single model. A snapshot of an airport snack shelf becomes structured information around brands, ingredient, and nutritional value. A walkthrough video of a living room combined with the user's Instagram feed becomes a joint signal about the room's aesthetic preference, current style trends, geometry. It uses a 3-tier reasoning stack: instant mode for quick answers, thinking for regular, and contemplating for high-stake questions. In this mode, the system spawns multiple internal agents. Each agent inspects a candidate's answer from a different angle and is tasked with finding flaws in others' reasoning. Final response is synthesized from this internal data. While testing surfaced issues, though, users reported token exchange errors, login failures, and a clunky interface. Meta's own announcement page shipped with a 3.5 megabyte hero image loaded slowly. The model also sometimes triggers contemplating mode on trivial inputs like "hey," spinning up many agents and burning large number of tokens, which is the unit of compute, each tied to real energy and server. Even with rough edges, Muse Spark makes sense for Meta on one simple axis: cost and control. With billions of users hitting search DMs across Facebook, Insta, WhatsApp, sending all that traffic to OpenAI or Anthropic would be like running a city on imported diesel. This way, they have their own power plant, but not the most advanced reactor yet, and it's reasoning with clear holes. But once online, every query, agent, feature runs on Meta's own compute, rules, and cost.